Welcome to cryptography session. Today I am going to give an explanation for block cipher mode of operations. So if you go for a symmetric encryption, there are three different techniques are available, which are all namely DES, SDES, and AES algorithms. So if you consider these three algorithms contains a fixed number of block size of plain text and key size. So if any plain text size is beyond the particular level, we cannot able to implement those algorithms in a required manner. So for avoiding this situation, we shifted to different mode of operations in which the plain text is fixed into or divided into equal size of blocks, and for all the blocks we may able to implement these three algorithms individually. So basically 5 types of block cipher mode of operations are available, which are all called electronic codebook, cipher block chaining, cipher feedback mode, output feedback mode, and counter method. So these 5 methods may able to implement both DES algorithm and also AES algorithm. We may also implement these modes either in a block cipher mode or a stream cipher mode. The first technique is an electronic codebook. In a short form, we can say that ECB. So in this method, a plaintext or a message is broken into independent blocks, and each blocks should contain equal size of plaintext in it. For all the blocks, we may implement a single key. So the same key may be used for all the blocks. So consider in this encryption mechanism, so this is the electronic codebook encryption mechanism, in which for all the plaintext block, a DES algorithm is implemented with the key called K1. So here PICA is available, where I refers the block number. So I is the block number. So if you want to implement the DES algorithm, each block should contain a 64-bit value. So if more than 64-bit values are available, we divide into 2 blocks or 3 blocks. So depending upon the size of message, that message is broken into 64-bit of blocks. For all the blocks, we implement this DES algorithm. So the concept is represented in a diagrammatic way. So here P1, P2 are block number. So totally n blocks are available. So Pn. So each block is implemented with the DES algorithm. So each block size is 64-bit. And the ciphertext is also 64-bit. For all the blocks, the same key is used. So what are the key used at block 1? The same key is used at block 2. The same key is also used at Pn, that is block n. So this is the encryption mechanism. You may able to implement all these blocks encryption mechanism in an independent manner, or parallelly we may able to implement these encryptions mechanism. So that is the advantage of electronic codebook. At the decryption side, the same key is used. For all the ciphertext blocks are decrypted with the same key, and we may able to get the corresponding plaintext value. So the advantage is we may align those messages as a sequence of blocks. For all the blocks, we may implement the same key value. So all the blocks encrypted message may run independently. So that is the advantage of this one. The second method is cipher block chaining method. In this method also, a message is broken into equal size of block, and one block encryption value is linked with its consecutive block. So that is the linking. So we should link the output of first block value to its successive block. So there is a chaining reaction in it. So this is the diagrammatic way. So plain text value is encrypted with the help of K, and answer will be retrieved from the first block. It is called as C1. So the ciphertext value is also given to the input of second block. but already the second block contains the P2 of, if I'm using DES algorithm, this P2 is 64-bit. This P1 is also 64-bit. For 64-bit of plaintext, I may able to retrieve 64 of ciphertext. But the output of first block value is given to the input of second block, means we should do XOR operation. So the same way, its consecutive values will be given to its successive blocks, and we should do XOR operation of both plaintext value and its ciphertext value. But if you consider first block contains only 64 values. So at what value we should do XOR operation for implementing first block notation? So this is called initial vector. So initial vector means it is a constant 64-bit value. This constant value is initially XOR with the first block. Then we may able to implement the same XOR operation with the help of output of its previous ciphertext value. So this is the encryption mechanism. So if you consider cipher block chaining decryption algorithm, we only connect the ciphertext value to its consecutive block. So the same ciphertext value should be used for decryption also. So the arrow from C1 to C2 is like this. So we may able to decrypt that value. So corresponding 64-bit values are available. We should do XOR operation because at encryption side, before encryption, we are implementing XOR operation. So for decryption side, after decrypting the value, we should implement XOR operation. So the same initial vector of 64-bit value is XORed with the decrypted value, then we may able to retrieve P1. So if you want to get P2 value, after decrypting C2 with K, the output of 64-bit second block decrypted value is XOR with the previous block ciphertext value. So the diagram is reversed in cipher block chaining decryption algorithm. So if last block is less than the equivalent size, we should add padding bits. So that is the main reason for implementing these techniques. And the third method is cipher feedback mode. So it is treated as a stream of bits. So instead of block, we are taking as a stream mode operations. In previous two methods, that means in electronic codebook and cipher block chaining, we are implementing encryption mechanism for plaintext. But in a cipher feedback mode, we are implementing encryption mechanism for initial vector. So we are only taking a S bits value. From that S bit, we are selecting 64-bit values. So here if you are using DES algorithm, this K value is 56-bit. So we are only selecting 64-bit from the initial vector. So it is called as a stream mode operation. So the encrypted 64-bit value is available. Depending upon the requirement of plaintext bits, we are only selecting its equivalent S bits values from the encrypted notations. That is the answer. So the same chaining reaction is done at cipher feedback mode. So the output of ciphertext value C1 is given to the input of second block. So this is the encryption mechanism. The same diagram is written for decryption also. So the diagram is same, shift register, encrypt with 64-bit. You are having the initial value and you should do the XOR operation with the help of ciphertext value we are retrieving plain text. So the same C1 should be used for next block. So instead of decrypt, we are only doing encryption at decryption algorithm also. So the upper part is encryption, lower part is decryption, but both these algorithms we are doing only encryption mechanism. So this is the cipher feedback mode. So advantages, we are only using stream mode operations. So number of bits are selected. So if a plain text contains n bits, we are only doing n bits of encryption or decryption purpose at both ends. So this is the advantage of cipher block chaining. And the fourth method is output feedback mode. So the same diagram of cipher feedback mode is available. Instead of retrieving the ciphertext value C1 to the input of second block, we only retrieve the previous S bits value to the next block. So in CFB method, we are taking the C1 value from first block to second block. But in an output feedback mode, the output of after encrypting S bit value is given to the input of the next block. So this is the difference between CFB method and OFD method. So here also the fourth method is counter method. So it is a new mode of operation. It is also similar to output feedback mode, but instead of encrypting an initial value or encrypting a plain text in a counter method, we are encrypting counter value. So counter means it is a constant value. So counter is a constant value which is implemented for encryption, and that value is XOR with the given plaintext value. This is also an independent method. This is like an electronic codebook mechanism. So we are doing encryption XOR operation at encryption side. So at decryption also we should do the same encryption mechanism for implementing XOR operations with the ciphertext value for retrieving plain text. So this is the counter method algorithm. So using these 5 different modes of operations, we may implement different symmetric encryption algorithm. So this table gives an overview idea of 5 modes of operations with their applications. So the electronic code bus is applied in an encryption mechanism for secure transmission of single value. If you want to implement authentication with block-oriented transformation, we may shift to cipher block chaining. Instead of block-oriented, if we are in need to implement a stream-oriented, then CFB method is the best one. If any transmission is done through a satellite communication, we may able to choose an output feedback method for doing encryption mechanism. For high-speed requirements, counter method is the best one. So depending upon the requirements of application, we may able to select any one of these 5 modes of operations. Thank you.